G'day, JD from FluxFocus here again. I'm going to do a C# example of LED blink on the embedded master, and I've got the MF deploy tool here up on the screen at the moment, so if you happen to have that up on your screen, just close that. And I'm using Visual C# 2008 Express Edition, and if I go to new project, and if you've got the micro framework installed correctly, then that'll be under Visual C#, and you can come down here and make a micro framework application. It's this one's going to be a console application, and we're going to call it LED blink test. And if I go over here into the Solution Explorer and open up Program CS, and it will have created some default code for us, and we're going to leave all of that in there anyway. The system isn't needed. The Microsoft Spot is needed for debug, and usually you leave system in there anyway, but whatever. Over here in references, we need to add a couple of references for this, and one of them is the embedded master library, and if it's not in your list here, you'll have to browse into the GHI SDK and add it into this list. So you'll find this library in the GHI embedded master SDK. So we're going to add that one. We need to add a Microsoft Spot hardware for doing stuff with ports, and native is already there. Okay, I think that's about it. The native is used for the debugging resources, and the embedded master library, of course, there's references to particular pins of the embedded master itself. Add some references over here, and Microsoft Spot is already there. That's being used for debug. We're going to put in system.threading. We're going to use that for some time delays, and the GHI electronics.hardware for the pins, and the system spot hardware for the output port. Sorry, Microsoft hardware for doing some port manipulation. And that's it for those includes, and we're going to leave this in here. So with micro framework, and I guess this happens for non-micro framework applications as well, but debug.print will print a message out of the debug port, which is a USB port out of the embedded master. So if you need some messages about what the embedded master is doing, that can be sent out of the debug port of the embedded master. And in this case, we're going to resources, and we're getting a string called string1. And if we go into resources, you'll see a string here which has been named string1, and the value is hello world. So you can guess that back in the program, that when we come along to debug.print, that this will print out hello world into the debug output. So after it does that, we're going to set up an output port, and as per the examples that are given by GHI will use some of their formatting and names. And here we have to specify what the pin is of the CPU and what the initial state is going to be. So for the embedded master, that comes from embedded master.pins, and the particular pin that we're going to be using is ET47. And even though I'm setting this to false, even though I'm setting that to false, if I go to the schematic, so this is the embedded master symbol, and so pin 1, 2, 3, 4, but these are the pins that are referenced. So ET47 is the one that we're looking for, and that's down here. That pin has a couple of other functions, but as a GPIO pin, it's known as ET47. And I've got the LED round in a particular way that if ET47 is false or 0, the LED will be on, but for this particular application that doesn't really matter. The next thing we're going to do is, now that we've set up the output pin, or out pin, which is what we've called it, we're going to just do a forever loop here, and just down here we'll have out pin dot write and the state. And I know it started off with false, but that's okay. And here we're going to create a sleep thread that's going to last for 500 milliseconds, and then when it comes out of that we'll make the LED switch to the other state. So in fact when it's false the LED will be on, and when it's true the LED will be off. It's just that that LED is active low. And that's pretty much it for the program. If I go up here to build solution, and it would have already shown us errors here if there was anything wrong, but the builds worked okay as well. Before we go to the board, we need to go into project and the project properties, and in .NET Micro Framework settings for deployment, there's an emulator, but the emulator refers to the GHI Embedded Masters development board, and we're going to use USB, and you'll see in the drop down list that the device is none at the moment, and that's because I haven't got the cable plugged in. So if we go to the board, and I'll do that now, the connector's down here at the bottom, and if I plug that in, and now if I click on the drop down list, that'll be populated with the embedded master. Let's go to build and deploy LED blink tests, and start debugging. And on the video back at the board you can see that the LED is now blinking, and here's the output window, and hello world, and that's it. Thanks for watching. The next one I'll do is just button press, and we'll probably make an LED do something on the button press. Cheers.